Okay, we're going to look at a equilibrium calculation problem. We're given from the entry ticket done the other day in class. The system that we're looking at is a gas A reacting with a gas B in equilibrium with 2 moles of a gas C. Our given information is that we have a Kc equal to 2.5 times 10 to the negative 8th. We have the concentration of A initial as being 0.15 molar. We have the concentration of B initially being 0.35 molar. And we are asked to find the concentrations of A, B, and C at equilibrium. So the unknown is equal to a concentration of A at equilibrium, concentration of B at equilibrium, and the concentration of C at equilibrium. Now there's a couple things to note. This Kc is very small because it's 10 to the negative 8th. So the Kc being very small, what does that mean? Well, remember, K roughly is the concentration of the products over the concentration of the reactants. That's a general term. Do not ever write that for an equilibrium expression. Okay? But since it's very small, this means I have very small amount of products present. So very small amounts of C present at equilibrium. Okay. The other thing that we note looking at the given is that this is an equilibrium table. So we probably should draw a ice table. In the ice table initially, we have 0.15 molar A and 0.35 molar B. Since C isn't mentioned, there is none. So likely I'm putting A and B into a container, and it implies that there is no product. Hopefully you can see, since there is no product, that the equilibrium or the system is going to shift to the product to come to equilibrium. So when it shifts, I'm going to lose an amount x of A. I'm going to shift an amount x of B. Now, because of the stoichiometry in this problem, for every 1 mole or molar of A that reacts, I'm going to get 2 molar of C. So that's a plus 2x. So at equilibrium, my concentration of A will be 0.15 minus x. My concentration of B will be 0.35 minus x, and my concentration of C will be 2x. Now, but I know that my Kc is very small. So I can make this assumption that that shift x is going to be very small compared to 0.15 and 0.35 molar. So what I can say then, so therefore, 0.15 minus x is really going to be equal to 0.15. So we're going to make this assumption to make the math easier. Okay. So Kc, the expression for Kc is the concentration of C squared over the concentration of A times the concentration of B. Well, Kc is 2.5 times 10 to the negative 8. That's going to be equal to 2x squared over 0.15 times 0.35. Solving this equation for x is equal to 1.81 times 10 to the negative 5. What I need to do at this point is I need to make sure that my assumption is correct. I need to verify the assumption is correct. Verify assumption correct. What I'm going to do is I'm going to take that x times 10 to the negative 5. I'm going to put it over 0.15, and I'm going to multiply it by 100. I want to make sure that that is less than 5%. It is less than 5%, so I'm going to show my instructor that I've checked, and somewhere in my problem I'm going to say 5% okay. If you're paying attention, I haven't quite yet finished my problem. So, my concentration of A, if I take 0.15 minus x, I still get 0.15 molar. For my concentration of B, 0.35 molar. And for my concentration of C, x is 1.81 times 10 to the negative 5th, but my C is 2x. 2 times that is 0.36 times 10 to the negative 5th molar of C.